Hey, how's it going? Mr. Schachter here to guide you through a linear inequality word problem. The problem says a school carnival charges $4.50 for adults and $3 for children. The school needs to make at least $135 to cover expenses. So we're going to let X be the adults and Y be the children. This should be like the number of adults, not the price. We already have the price, right? This should be the number of children, not the... There's both quantity. We already have the prices. It says write and graph an inequality. All right, so step one is to make an equation. So first of all, if they charge $4.50 per adult A, and then plus $3 for every child Y, well, we're going to use X and Y. And then it says they need to make at least $135. So at least $135 would mean a greater than or equal to $135. All right? The next step would be to put this into slope-intercept form. So you'd want a minus 4.50x minus 4.50x. So we get that 3y is greater than or equal to negative 4.50x plus 135. And then we're going to divide everything by 3. Divide by 3. And we're going to have an answer of y is greater than or equal to negative 4.5 divided 3 is negative 1.5x plus 135 divided 3 is 45. Okay? So our job now is to graph that. That is the equation we need to graph. And so the y-intercept is 45 and the slope is negative 1.5. So if I were to graph this, let's use blue for the scale. Let's see, what would a good scale be? We have to get up to 45, so maybe 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45. There we go. And the x scale could probably be 1s or 2s or 3s. I think we should do 3 if we have to go, if our slope is going to be negative 1.5. Although it really doesn't matter because the x values that run, we'll just make it 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we start off by doing the y-intercept. The y-intercept of this graph is positive 45 right up there. And then we're going to go slope of negative 1.5 means we go down 1.5, right 1. So down 1.5, right 1, so it's just going to be down a little bit more, and a little bit more, and so on and so forth. And each time we go over 1, we're going down 1.5. Okay? So on and so forth, so on and so forth. Now, because we have a greater than or equal to line, we have a solid, or a greater than or equal to inequality, we have a solid line. It's not dashed because it's not strictly greater than or strictly less than. All right? The shading. The inequality is a greater than or equal to, which means we need to shade above the line. We need all solutions greater than our line. Okay? So everything up here is a solution to the inequality. Specifically, the problem asks us to find 2 solutions to the inequality. Well, let's go ahead and plot a few. We'll use a nice green. So this is a solution to the inequality. This is the point 7, 45. 7, 45 is a solution. That means that if 7 adults attend, because adults was X, so this is 7 adults and 45 children. That means if they have 7 adults and 45 children enter the park, that they will meet their goal. They'll make at least $135, right? What's another solution? Well, let's find one. Anything in the shaded region. Okay, how about this one right here? This is another one. 9, 40. 9, 40. If 9 adults attend and 40 children attend, they will meet their goal, right? So there's a lot of solutions. There's one here, there's one here, there's one over here. In fact, because the line is solid, every single point on the line itself is also a solution. Okay? So that's the idea. Anything in that highlighted region is a solution, including the point 100,000, 1, 2, 3, there we go, 100,000, 100,000. That's a solution as well, right? So what's not a solution? Well, anything below the line right here is not a solution. Anything over here in the negative region is not a solution. Anything to the left right here, over here, anything right over here is not a solution to this particular problem, but anything in the highlighted region is, okay? It's important to talk about the fact that the solution here does need to end and live in the positive region here, right? When we're talking about a word problem, we're talking about positive values. So we could not exceed to negative x values or negative y values because they would not be, they wouldn't make any sense, right? We're talking about number of children, number of adults who go to a park. And if you have negative adults and negative children, the problem doesn't make sense. So make sure that your solution does not extend beyond this point right here. All right, so it's going to kind of live right there in this little region, this little box, okay? All right, I hope that was helpful.